Alright guys, today we're going to look at graphing trig functions, primarily graphing sine and cosine. So from now on, whenever we have a trig function, it's going to be preceded by y equals or f of x equals. So if you just take a look right down here, you'll have our trig functions. Y equals sine of x, f of x equals cosine of x, and so on and so forth. Now we're going to talk about sine first. The sine of a function has a period of 2 pi. That's very important to recognize and commit to memory because that is something we're going to refer to over and over and over again throughout the entire semester. It is only necessary to graph y equals sine x on the interval from 0 to 2 pi, and that's because it's periodic, aka it's cyclical. Any other part of the graph is just repetitions of this one section. So every 2 pi intervals, you're going to see the same graph over and over and over again. Now, when I choose to graph, I only choose 5 points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. That's because those are my critical points in which I'm going to get the most bang for my buck. The other points just help make that smooth curve. A couple things you want to know about the graph of y equals sine x is the domain is the set of all real numbers. The range is from -1 to 1 inclusive, means I can include -1 and +1. The function is odd, so there's symmetry with the origin. And the period is 2 pi, so it's cyclical. And right up here, it even says one period or one cycle of the graph is y equals sine x. It's cyclical, meaning it's going to repeat over and over and over again. And then we have our x-intercepts and then our maximums and minimums. So when we go and do an example of graphing, we have the graph y equals 3 sine x. And it says to graph using transformations. So first, I'm going to do the parent function of y equals sine x. I know that I'm going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then I'll have negative pi over 2 and negative pi. The graph of sine starts at 0, 0. And we know that the range is 1. So I go to 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 0, 2 pi. Or 2 pi 0, my apologies. And then I'm going to repeat the same on the left-hand side because it's cyclical. Now I'm going to fill in my graph of sine. Now I apologize, my graphing skills on the computer are not great. You'd think after, through all this pandemic stuff, they would have gotten better, but they haven't. So here we have the graph y equals sine x. Now the period occurs from here to here. This is one period. One cycle of the graph. So this is one period. All right, but now we have to graph y equals 3 sine x. Now, if you remember from Algebra 2, when we had a number in front of our function, that meant we were either going to compress it or stretch it. We compressed it if it was a fraction between 0 and 1, and we stretched it if it was a fraction greater than, or a number greater than 1. So this means we're stretching by a factor of 3. Which means our zeros stay the same, but every other point has to be multiplied by 3. So pi over 2, 1 is now pi over 2, 3. And 3 pi over 2, negative 1 is 3 pi over 2, negative 3. And so we just go ahead and we fill in our sine function. I'm not going to lie, I'm pretty impressed with what I just did. So the graph in green is y equals 3 sine x. Now notice, they still have the same period length. They both start at the same place and end at the same place. The only difference is the height of the graph, which, by the way, is called the amplitude. All right, let's go ahead and do this again. But we're going to get a little bit more complicated here. It says go ahead and graph y equals -2 sine of 2x. All right, so just like before, I'm going to graph y equals sine x. So I have my pi over 2, my pi, my 3 pi over 2, and my 2 pi. I'll go ahead and do my left-hand side. And we have 1, 2, 3, -1, -2, -3. All right, so we know it's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. And we continue the pattern. So let's go ahead and fill in y equals sine x. And now let's take a look at y equals -2 sine 2x. All right, so we know the negative is going to do what? It flips it. It reflects it. It flips it, however you want to talk about it. All right. The 2 stretches by a factor of 2. And important to note, that is a vertical stretch. Because now the 2 on the inside is actually a horizontal compression. Now you're like, Miss Younger, what the world do you mean horizontal compression? Well, if we take a look at the 5 points that we graphed for sine of x, we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, if we're compressing it by a factor of 2, that means we divide each of these by 2. So we divide by 2. So 0 is still 0, but now pi over 2 is pi over 4. And then pi is pi over 2. 3 pi over 2 is now 3 pi over 4. And 2 pi is pi. So now, instead of it having a period of 2 pi, my entire graph has a period of pi. So one cycle goes from 0 to pi now. So if I were to graph this, here we have our pi over 4 and our 3 pi over 4. We know that it is negative, so instead of going up to 1, we're going down, but to 2 because it is by a factor of 2. So now we start at the same point, we stretched it by a factor of 2, and then we go up, now it's important to note here, our y's, everything shifted. So if we were at 0, we stayed at 0. But positive 1 went to -2. 0 is still at 0. -1 is now at +2. So here's our y's just to help you out. And pi is at, once again, 0. So here we have 0, 0, pi over 4, negative 2, pi over 2, 0, 3 pi over 4, 2, and pi 0. And if we can keep going through that cycle to fill it out, but here our period has changed. We have a complete graph from 0 to pi. We have one period right there. Now we can continue this, and I will, just because we like the continuity. And the green y equals negative 2 sine 2x. And like I said, I really apologize for the really pretty graphing. All right, so that was graphing sine. Now let's graph cosine. The cosine also has a period of 2 pi, and it's only necessary to graph y equals cosine x on the interval from 0 to 2 pi. The remainder of the graph is still just repetitious. Once again, I only graph 5 points. We have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi. Notice how this graph actually starts higher at 0, 1, has a big dip, that valley at pi, and then comes back up at 2 pi. One period, or one cycle of the graph is still, this is what happens when Miss Younger copies and pastes, cosine x. The domain is still the set of all real numbers. The range is still negative 1 to 1 inclusive. Cosine is an even function, so it has symmetry across the y-axis. It is periodic with a period of 2 pi. And then we have our x-intercepts and our maxes and our mins. Let's go ahead and do some examples. So we have y equals cosine x. And when I graph that, I know that I'm still going to have pi over 2, pi, 3 pi over 2, 2 pi, positive 1, negative 1. All right, so we actually start at 0, 1, come down to pi over 2, 0, come down to pi negative 1, and then start to go back up. And so we get this beautiful cosine function. Y equals cosine x. Now, when we look at y equals 2 cosine 3x, once again using our transformations, we're going to stretch vertically by 2, but we are going to horizontal compress by 3. So we had the point, the x is 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now, everything has to be divided by 3 because we're doing a horizontal compression of 3. So instead of having a period of 2 pi, our period now becomes 2 pi over 3. So the entirety of our cosine function is going to be fit between 0 and 2 pi over 3. Here's our x's. Now our y's, remember, are being pulled by a factor of 2. So if it was 0, 1, it's now 0, 2. If it was pi over 2, 0, it's now pi over 6, 0. If it was pi negative 1, it's pi negative 2. 3 pi over 2 went to pi over 2, 0. And then 2 pi to 2 pi over 3 is now 2 pi over 3, 2. So now we have to figure out where these intervals lie. So pi over 2 is kind of the same as 3 pi over 6. So I'm going to do pi over 6 intervals. So 1 pi over 6, and then 2 pi over 6 is pi over 3. And then we have pi over 2. And then after pi over 2, we get 4 pi over 6, which is 2 pi over 3. So now the entirety of our sine function is going to fit between 0 and 2 pi over 3. So we get 0, 2, pi over 6, 0, pi over 3, negative 2, pi over 2, 0, and 2 pi over 3, 2. Now we can continue that pattern on. So on and so forth. That's going to be a lot of dots, so I'm just going to go ahead and fill in what we need, just a little bit. And I can continue on. So on and so forth. And this is y equals 2 cosine 3x. If you don't have graph paper, I would really suggest investing in graph paper. Our next few sections are all about graphing. All right, so now we're going to talk about sinusoidal functions. And if you didn't realize, sine x and cosine x are very, very similar. In fact, they're so similar that if we were to shift cosine over by pi over 2, the two functions would line up. So here we have y equals cosine x and y equals cosine x minus 2. But if you notice, the blue lines up perfectly with y equals sine x. Just know that that simple shift over to the right, pi over 2 units, gives us that sine function. Now, a big thing you need to memorize, because you will be tested on it, is the amplitude and the period. So when we have a function, if our omega is greater than 0, the amplitude and period of y equals a sine omega x and y equals a cosine omega x are given by. The amplitude is the absolute value of a, and the period t is 2 pi over omega. You will be asked to find the amplitude and period of several functions. So just commit that to memory. So here we have y equals a sine omega x. So our amplitude is the absolute value of 5, and in this case it is 5. And our period t is 2 pi over omega, which is 2 pi over 3. Nice and simple that way. All right, so now we're going to actually talk about graphing sinusoidal functions using key points. And this is what I really like about graphing is trig functions, is that it is so very methodical. So step 1 is always determine the amplitude and period. So step 1, a equals 2 the period of period t equals 2 pi over omega is 2 pi over 2, or in this case, it is pi. Step 2 is divide your interval. So our interval was pi. So from 0 to pi, we need to split that into 4 sections. So you just take the pi and divide it by 4. So my subintervals are pi over 4. And that is really important, because now we have to make our ordered pairs. So we have our x and our y. We know we start at 0, and then we'll go to pi over 4, and then another pi over 4 is pi over 2, and then another pi over 4 is 3 pi over 4, until we get to our last point of pi. Now, it is sine, so we know we are starting at 0. And we know it has a vertical stretch of 2. So typically, using that subinterval, our next point would be 1, but because we have that stretch, it is 2. Then back to 0, then down to -2, and then back to 0. So that was step 3. Step 4 is to graph. So we have pi over 4, pi over 2, 3 pi over 4, and pi. And I'm only going to be graphing one period of this, and we know that it's going up to 2. So we have 0, 0, pi over 4, 2, pi over 2, 0, 3 pi over 4, -2, and then pi 0. And here we have one period of y equals 2 sine 2x. Typically, you only ever need to graph just one period, because once again, it is cyclical, so it just repeats that same pattern over and over again. All right, so for this next example, we have to remember your odd-even properties. This is a sine function, so it's odd, which means I can actually pull that negative that's inside out to the front. So our amplitude is 4, so that's the height of my sine function. The highest it's going to go is 4, the lowest it's going to go is -4. Now, to find our period t, it's 2 pi over omega, so it's 2 pi over pi over 4, which is actually 8. So this time we actually have a whole number. We're going to divide that into 4 intervals, so our intervals aren't intervals of 2. So we have 0, 2, 4, 6, 8. And then we have 0, -4, 0, 4, and 0. Because it is a sine function, we know it starts at 0. We know the lowest it's going to get is -4. The highest it's going to get is +4. Now, the reason why we went to -4 first was because we reflected. So here we go. 2, 4, 6, 8, 2, 4, -2, -4. So we have 0, 0, 2, negative 4, 4, 0, 6, 4, 8, 0. And once again, we are just graphing one period, one part, one section, one cycle of this sine graph. So this is now y equals 4 sine of negative pi over 4x. All right, let's do this again. However, this time it's a little bit more tricky. One, we're dealing with cosine. Not only are we flipped and vertically stretched, but now we actually have a vertical shift to play with as well. So first things first, amplitude equals 4. Our period is 2 pi over omega, which is 2 pi over pi, which is 2. So now I have to divide 2 by 4, so our intervals of 1/2. So when I make this t-chart, I have 0, 1/2, 1, 3/2, and 2. Now let's just take it bit by bit. First things, here's our x, here's our working y. All right, we know that cosine normally starts at 0, 1. However, we have a negative 4 as an amplitude. So we're actually starting at 0, negative 4. All right. And then 1/2 would go to the 0. 1 would go to the positive 4. 3/2 would go to the 0. And 2 would go to the negative 4. But that does not take into the account of our vertical downward shift of -2. So we have to subtract 2 from each of these to get our actual y value. So this becomes -6, -2, +2, -2, -6. So when we graph, we have 1/2, we have 1, we have 3/2, we have 2, and we have 2, 4, 6, -2, -4, -6. So we know that we're not actually looking at this y value, but we're looking at these y values. So we get 0, -6, 1/2, -2, 1, 2, 3/2, -2, and 2, -6. Now when we graph this cosine function, we'll see the one period outlined. All right, so we have graphed sine using transformations. We have graphed cosine using transformations. We have graphed sine and cosine using our critical points and by learning our amplitude and our period and our subintervals. Now we're actually going to work backwards. We have to first identify if our graph is sine or cosine, the amplitude, and the period. So it gives us our period of 4, and we have an amplitude of 2. Now, is this sine or cosine? Well, always look at the origin first. It's at 0, 0, which means it's going to be a sine function. So we have y equals a sine omega x. Well, our period, or our amplitude, is our height of our graph. And so our height is at 2. Boom. Now our period is 2 pi over omega. And if we look over here, our period spans from 0 to 4, so our period is 4. So this means we have 4 equals 2 pi over omega. So 4 omega equals 2 pi. Omega equals pi over 2. So our answer is 2 sine pi over 2 x. And Miss Younger, come on. Y equals. Can't forget our y equals. Okay, for our last example of this video that I went really fast on, do we have sine or do we have cosine? Well, we're at 0, 0. Once again, we have a period from -4 to 8. All right, so first let's find our amplitude. It's the height. Our height goes to 1, 2, 3. So height is 3. Our period was 8, so that's 2 pi over omega. So 8 equals 2 pi over omega. 8 omega equals 2 pi. So omega equals pi over 4. Because we started at 0, 0, we know that it is y equals what? -3. Notice, we went down first. So -3 sine pi over 4 x. All right, that is the end of this video. Graphing sine and cosine is easy, but it does take practice and just memorizing those 5 key points for each of the graphs. If you have questions, please, please, please let me know. Thank you.